So, about 15 minutes ago, I had an idea on building an internal spline cutter. I think that's what you would call it. I'm not really sure what you call this thing. I'm not even sure if it's going to work or not. So, I've been trying to figure out how to cut internal splines. And I came up with a device that we're going to hopefully make in this video to be able to do that using my rotary table that I got off my vertical mill, and using just a bunch of scrap material that I have laying around. Now, is this gonna work? I'm not entirely sure. I think I can make. I built my own homemade lathe. I should be able to build this. It's just gonna take a little time to work it out and try to figure out how to make it work. But now I'm gonna try and explain how and what I'm doing as best I can. But I work best by just building it and then figuring out how it's going to work as I go. So as I go, I'll try to explain as best I can, but for now, let's just start cutting materials and start placing and figuring out how this thing's going to work, and then as I go along, I'll figure out how to build this thing. So because this table is kind of tiny, I'm kind of limited with how to mount this or how to bolt this down to the table. This is like one of the ways I could do it, but it's still, what I need to do is I need to clean up these edges right here, and I obviously can't stand this thing on end and use this. So what I need to do is use this and then just do that. But as far as mounting it to the table, this is not really going to work, so I had an idea of just drilling 2 holes in the middle. Therefore, I can run these bolts through here, through the middle of this, and then bolt it down like that. That's gonna make doing all the other operations to this piece a lot easier. So let's just drill a couple holes and make this thing a lot easier to work on. Alright, so we just finished the main piece of the internal spline cutter that we are making. This is actually very similar to how I made my homemade lathe. I decided to do the 90-degree style of ways instead of doing the dovetail style, just because dovetails are a little bit more complicated, a lot harder to do on such a long dimension, especially when you don't have perfect machinery. This piece right here was actually not perfect. When I finished milling it, I actually measured this dimension and these dimensions, and they were like 15 to 17 thou off. Now, that is definitely not good enough. Would have made it to where this would bind up really, really bad. And after hours and hours and hours of filing these surfaces, I got them down to 1 to 2 thou off. Now, they are very close to final dimensions, but they're still not perfect. You can see it slides over here perfectly, but over here it does bind up a little bit. It just means I have a little bit more material to take off down here, but for now it works good enough to where we can move on to something else. Now, let me actually explain what it is we're doing. I don't think I've done that yet. Let me explain what it is we're building. Alright, so I had to figure out how to make this move back and forth without making it overcomplicated, without having too many moving parts. I just basically wanted to do this as simple as possible. So at first, I was thinking using a Acme thread and just have a handle right here. You turn the handle and it slowly moves this back and forth. Now, this is not perfect. We would have a lot of pushing force. You can get a lot of force from one of these things, but it would move very slowly, and due to, having to cut multiple teeth, probably doing multiple passes on each tooth, this is not perfect because we'd have to move this thing back and forth quite a lot, and we'd have to sit there for a really long time cranking a handle, and it's not really the perfect way to do this. So Acme thread is out. Then I had a thought of using a rack, just like the way a lathe carriage moves, using a handle, gearing, and then this be stationary with this. Turn the handle and it moves. It would move a lot faster, but we would lose a lot of pushing force using this method, so I could probably do some type of gear reduction to make up the force using this, but again, that is a lot of moving parts, overcomplicated. I don't want to do that. I want to make this as simple as possible. So we're using this. This is a linear actuator. You put angry pixies in one direction, it makes it move. You flip it over, put angry pixies in the other direction, and it moves in the other direction. This is going to be the simplest way to do this. You connect this end to here, you connect this end to a stationary thing, you press a button, and it moves slowly. It is going to move a little bit slowly, but it's a little bit better than having to sit there and crank a handle. All you have to do is just press a button. So, unfortunately, when I bought this on Amazon, on the listing of this, it said that this produces 600 pounds of pushing force. I'm like, great, that's plenty. But unfortunately, once I got this thing here and I'm reading the label, it says 400 pounds of pushing force. So that's some false advertising right there. That's a bit unfortunate, but I still think 400 pounds should be plenty. We're not cutting terribly big teeth, so this should work plenty. Alright, so I'm going to try and explain how this thing's going to work. I know I'm not the best at explaining stuff, so just bear with me. I'm going to try my best. So we're going to mount this down here. We're going to be able to mount any type of workpiece to here and then index it to however many teeth we need to cut. I need to build something just like this. I did think about using this, but it's a little... This is actually the compound slide that I built for my homemade lathe, and it's able to turn in any direction. You can clamp it down using these screws, and then you can turn this handle right here and it makes it move up and down. I did think about using this for this machine, but I kind of want to save it for my homemade lathe, plus we can build a better one. So once we build this, we can mount it right here, just like this, perfectly 90 degrees up and down, mount it to the part that slides back and forth. Then we can mount a tool right here that can move up and down due to this. It'll slide back and forth thanks to this, and then we can cut internal splines. I'm hoping you guys understand what I'm trying to do with this thing. It's very, very similar to a vertical shaper, or a horizontal shaper. So I am kind of trying to build something very similar to that. I did think about trying to buy one, but they're kind of really expensive, and they're also very big. So I just want to cut splines with this thing, so therefore I'm building this. So I'm probably gonna have to end this video here. just because you know, this video is long enough, and I have already like filled up 2 memory cards with this video alone. So next video is going to be building this part, then adding it to here, and then possibly building the table that we mount all this stuff to. But I'm not really sure when we're gonna get to that, but we're just hopefully gonna get to that soon. So anyway, I gotta end this video here. Thank y'all for watching. I'll see ya in the next video. Yeah. What did I do? Is this thing broken? Let's try it again. Let's try and break it even more. Here we go. Okay, something's up. Something's broken. Oh, did I just break it again? I swear this thing's kind of a turd. Hang on. Yeah? I think I'm running this machine a little too hard. Yeah. That's some devastation right there. I think I know I'm running this machine too hard. Honestly, I can't do anything about it just because it's either be gentle on this thing and have it take forever, or just burn through gears that are plastic for some reason and just have to keep replacing them. Honestly, kind of bummed I bought this thing. I wish I got a bridge for it. I need a bridge for it. Unfortunately, I just have nowhere to put one.